Morning everyone, this is Karthik from TPF Software. Today we are going to see the webinar about the tracing of external ECBs from zTPFGI. Let me go to the, before going to the demo, I just wanted to give you a background of what is external ECBs and all of the things. Most of you all application programmer, you all well versed with external systems. In a real-time system, for example, if you are working on a hotel reservation, we might need to go to a corner to the external system. So we need to get the database and availability to the external system, and once we get the response from the external, we need to process the hotel reservation. This is one of the examples. And also maybe in a flight reservation, if you are booking a flight ticket, during the booking of the ticket, maybe we want to go to the credit card service to authorize the currency related things and get back to the reservation. So these are a few examples I'm just giving. I'm not much of an application programmer, so maybe you all can correlate this with your projects, I guess. So these kind of external ECBs you cannot directly capture in zTPFGI. So we have a tool called asynchronous trace. With that tool, you can able to trace that ECB. So that is what I'm going to take a webinar today. So users can capture the trace any messages which is going out of the TPF system and coming back to the TPF system. Maybe MQ messages or XML messages, or as the host-to-host messages. So there are different type of messages that is coming to TPF system. So users can set up a different criteria. Based on the criteria, you can capture those ECBs. I'll just go to the graphical view how it works. For example, I'm just taking the hotel transaction here. When the user giving the entry to the system, maybe that particular system having external connectivity. So we just go to the outside world. So before going to the outside world, we are maintaining a intercept criteria table. So based on that table, you just put the data there and going to the external system. So once the message going to the external system, the message will process on the external system and coming back to the given system. But the system may not know who's the right user or which is the correct line data to process. So again, we have the intercept criteria. It just go and matches the intercept criteria. If it is matches, then it just routed to the correct line data or the particular user. So this is how the external ECBs are working in the system. So I'll just go to the demo directly so that it'll be easy for you to understand. So now you can see I just opened a zTPFGI. This is the connect button. So I'm just going to connect now. So once click on the connect, you'll be able to see what are the systems available. So here I'm just set up in zTPF9. That is our test system, and just click that particular system and click OK. Once zTPFGI connected with the system, then you'll be able to see a new tab called System tab. So it will not be available if you are not connected with the system. Now you are connected with zTPF9, so you got the System tab. So let me just go to the asynchronous trace. Here is the asynchronous trace. We have different options in the asynchronous trace. So one is the IPC, that is capture the messages from my PC. So if I have any client machine, or else any web service, I'm just giving entry to that particular client. So I'll be able to capture that message. And next one is specifying the specific IP address. For example, a user is giving an entry from an IP address. So I just wanted to capture that particular entry. So in that case, I can use this IP capture by specific IP address. And the next one is the program. So for example, during the external process, so if I'm allocate a resource for program, So if the entry hits that particular program, then I'll be getting the control. Capture the ECB, that particular ECB, and then I can continue the process. So that is on the program asynchronous trace. And the next one is the error. That is a capture system error for a program. For example, in a system, there is a control 3 is happening. So you don't know at what time, what situation, or what user making that entry, but the system getting the control 3. So you can allocate a resource for that particular, maybe for that control 3. So whenever there is a control 3 dump in the system, the ECB will capture to you for your terminal, and you'll be able to trace that particular ECB. So that is on that option. And this is on the line data. In a project, maybe multiple developers are working on a single project. So in that case, me and Pierre are working together in a module. So if I give the entry, one of the other peer can able to trace. So you can use the line data option. So by setting the particular line data, you can capture their entries. So this is on the line item. So these are the few examples that I have. But in a customer environment, based on the customer requirement and based on their team and work, you can allocate a new resources. You can contact your customer support representative in your place, or you can send us a mail so that we can work on the synchronous trace and set up a new terminals or new options for you. These are a few examples that I have. I can just go ahead and show the demo for you now. I'll just take the first one, IPC, capture message from my PC client. So before going, I'm just click on the IPC. So once clicked, this is my IP 216.113.128.239. So if there is any entries from my IP, then obviously this particular terminal will capture that ECB. Here, we have developed a small tool which is sending from my PC, which is sending messages from my PC. So what I'm going to do is I'll just go and select the system. Just gave an entry. Now the entry is given in my PC client. So if you see the zTPFGI, this is captured that particular ECB, so that once it is captured, the user can set up any traces like all programs, all macros, like the other traces. They can just continue their operations like the other ECB traces. So they can continue, they can debug, or they can do their testing. So this is on the IP trace. I'll just let the ECB run. And once the ECB run, you can able to see this particular terminal is disabled. So if you are giving the entry again, I mean, I'm just going to give the entry now. So now in this case, you are not able to capture this message because this particular terminal is disabled. So the idea behind that is once we set up the criteria, I mean the IPC, so we just put it in the system like whenever there is a new ECB or any external ECBs coming to the system, it just searches for that particular IP. So right now I'm the only one connected to the system. So obviously it just searches, it just have one search entry. So for all the programs entering, it just searches for that IP. For example, multiple users are connected to the system, maybe 10 or 15 users connected. So they all having their own synchronous terminal. So they're not disabled. In that case, what will happen is 10 times there is a search will happen for each and every user. So it will be a overhead to the system. So we don't want to do that. So whenever the user required, they can use it. So once it is captured, it will be disabled. So if the user wants to capture again, then they can just do a right click and make it enable. And now you'll be able to see this ready status, and you can just go back and give the entry again. Now I can see the ECB capture. So this is to avoid the overhead to the system. Few customers don't want to do the disable. They know they are using a private system. It is not much users using the same system, so they are okay with the overhead. So in that case, we just keep it enabled all the time. It is based on the customer requirement. I'll just let the ECB run now. So now I can see this is on the disabled state. So I think you're all clear with the IP trace. I'll just, we have different options called release active, release all. If the user allocated more than one terminal resources, then they can release only one. They can keep the other one active. So now in this case, I have only one active. So I'm just releasing all.
Karthik, sorry to interrupt.
Yes, Chitra.
There's a question from David, so I'm unmuting him so that he can directly ask a question to you. David, you're unmuted.
We use Citrix to access GI, and it's my understanding that the IP address that comes in is the address of the Citrix box, not the individual user.
Yeah, I understand. What I'm saying is, these are all the examples. It is not the same case. We have to use these same asynchronous resource options. Maybe in your asynchronous trace resources, you will be able to see different options. May not be the IP. So what I'm saying is, I'm just giving an overall idea how the asynchronous trace is working, how external ECB is to be captured, so that it is not the default option. We're just getting the inputs from the users so that they are the right person to give the inputs because they are working in different platforms. So based on their inputs, based on their team, for example, if you are working on a ticketing team, you wanted to capture a particular ticketing entry. In that case, you have specific data like in one of the data level, you have certain values. So you can provide those information to our customer support executives. They can set up a particular kind of synchronous resources for you. So that will be easy for you to capture ticketing related entries. So if you are working on the DCS, same like each and every team have their own data kind of resources. So based on their requirement, we'll set up asynchronous resources. I'm just giving this as an example. May I answer your question?
Yes, thank you.
Let me go to the next option. Since we have our test system very small, it's a small test system. We don't have any vendors connected with, because we're not doing any application kind of thing. So we don't have any external system connected. I don't have the very proper example to show you all, but I'm just making things to be more understandable in the customer environment. You can understand, and based on your requirement, we will be able to set up the asynchronous list. I'll just go and show you the example of program trace. Click on the program, you'll be able to see a program tab here. Maybe any one of the program which you wanted to capture. I have a sample example program, UVA0. So what I'm going to do is, I'm going to allocate the resource for UVA0. Now, click OK. There is a terminal allocated for UVA0 now. So whenever there is a entry or ECB called the UVA0 program in the system, that will be captured to this terminal and given it to the user. So in this case, how I'm going to do is, I'm going to give an entry in one of the prime trash. So in the VPass directly, the entry to call the UVA0 is ZUVA0. That is what the entry. So I'm going to give that entry. So now I can see I don't have any responses because my ECB was captured here in zTPFGI. You can see that UVA0 was captured. So you can just continue your trace here. I don't set up any specific trace options here. So once I click the F10 or step into button, it just let the ECB. And also once it is done, it is went to a disabled state. So I'm just making enable again. I'm just going back to the system. You can see there are outputs for that particular ECB. So once it is captured the ECB, you don't get any response. So once I let the ECB run, I'm getting the response in the system. So you will be able to see clearly it is capturing the UVA0. I'm going to provide any other entries like here in this case, I got the response. The ZDSys is not calling that UVA0 program. So if you want to see, if you want, we can allocate one more resources. So I'm just going to allocate the program resource for one more program that is called COA4. You all know the COA4 is a IBM program. So each and for all the entries, it will be called. So I've just allocated the resource for COA4. I'm going back here. I'm going to give the same entry ZDSys. So in this case, you were not able to get the response because that COA4 captured your ECB. So you can trace that ECB. So whenever you are ready, whenever you are finished, you can let the ECB run doing the trace. So once I done with my trace, I can let the ECB run. So now trace. Now in this case, the ECB was run. And if I go back to the system, you'll be able to see the output. This is an example of program trace. I'm just releasing this particular resource now. Here, while doing the synchronous trace, people wanted to do a socio trace. Even you'll be able to do the socio trace. I'm just going to show you how to do the socio trace. Again, I'm just going to give the GUVA0 example. Just gave the entry here, and I'm going here. Now you'll be able to see the ECB captured. So I don't want to do the ECB trace. For example, I just wanted to do the socio trace. In that case, you have that option. I know you all aware of this option. Maybe I'll just drop anything. Just go to the socio and add SO to socio option, and type your program UVA0 and OK. Now you will be able to see that UVA0 locked in the source view. So once the program locked in the source view, just you can able to see that the control came to the source view. Now you'll be able to continue your trace. You'll be able to see the watch variables, call stack, variables, registers, ECB, and all the other values. So this will be used for the developers for their debugging purpose. So this is how you'll be able to do the source view trace. And I just wanted to give a few more things about the source view. Since it is external ECB, it is called from outside. So it just directly call the program which is activated system-wide. Some people, what will do is they just activated their programs selectively. So whenever the control comes, it just activates the system-wide activated program, not their selective activated. So their changes may not be executed. So we just recommend you to activate your program system-wide if you want to trace your own your loaded program in the asynchronous trace. So and also one more thing I wanted to tell you is if you want to capture a created ECB, please set up a synchronous trace for that parent ECB, not that child ECB. Sometimes the child ECBs may not be picked up correctly, so we are suggesting you to use the parent ECB. I'll just let the ECB go. Now if you go back to the system, you got the output. This is what the program resources. So I don't want any other resources. I'll just release all the resources. I don't want to give the overhead to the system. So I just released all the resources. Now you see only my resources will be available. The program resource was released. So I just wanted to show another type of asynchronous trace that is called error. If there is any error, system error in the system, you'll be able to capture through this option. So I'll just show you how to do it. Just click on the error option. So here we just coded a sample program which having system error. So the program name is PRA0, and the error number, that is the user defined error number. Even you can do the control or OPR dumps, but in this case I just coded my own circ number. So 7890, this is my error number. Just clicked OK. Now you'll be able to see a terminal which is allocated for that particular system error. Just going back here, and there is an entry called zTPFGI. This is our test program with option A. So I'm just giving that particular entry. This particular entry will give you a circ error 5656780, but that particular dump was captured here in the ECB. So you can see like the circ was called, this is the manual dump. So before calling that particular dump, the ECB was captured and given to that particular user. So the user can trace that ECB and do the debugging. So I'll just let the ECB go now. Now you'll be able to see the status is disabled. I'm just going back. Now you got the error. So if you want to give the entry again, you got the output because the status of the terminal is disabled. So this is how the error terminal working. I'm just released that particular terminal, and I'm just going to show one more option like line data. If you are working with your peer, you just wanted to capture his particular entry. In that case, you can be able to use this particular line data option. So here in this case, maybe I'm just again capture the COEA4 program. I don't have any terminal, so I'll just use the prime terminal address. Okay, just going back. I just given the entry from the prime terminal, so it just captured that particular line data particular program. So this will be more meaningful if I'm having another client and another terminal and giving the entry from another terminal. But because I have showing only my screen, so I'm just using the prime class terminal as a line data. So this is how you can capture. So these are all the examples of how to do the how to capture the external ECBs. It need not to be in the same way how we are having now. It is based on the user input and based on the customer. So please get in touch with our customer support team, any kind of trace options, so that we will be able to help you and set up a new asynchronous option. So in few of our customer places we done the customization. So if you wanted to do any kind of asynchronous trace option, please let us know. We'll help you on this. I'm done with my demo. Thank you, everyone.